Hello everyone, this is Mr. McMillan and I'm here with a video on the test review for Pythagorean theorem and trig, which is the whole of what we were doing with right triangles. So these first two pages, as I mentioned on the Google Classroom page, is simply a summary of everything that we've been doing, and it gives you some hints and tips on how to approach each type of problem and what the steps for solving that kind of problem are. Okay, so the problems on classifying triangles, finding missing side lengths, and finding missing angle measures. The important thing is, if you're looking to classify triangles, you need to use your a squared plus b squared equals c squared, and you calculate what a squared plus b squared is and what c squared is, and you look for one of these conditions. So if c squared is smaller, that means it's acute. If c squared is equal, that means it's right. And if c squared is larger, that means it's obtuse. Okay. On the missing side lengths, there are two cases that we think about when we do missing side lengths. The first one is you're only given two sides and you want to find the third side. Okay. You're not given any angles to speak of. You're just given two sides and you want to find the third side. Whenever this happens and you want to find that third side, you need to use the Pythagorean theorem. So you would identify your A, B, and C. Remember, C is always your hypotenuse, and then set that up and go from there. Okay. Then you would solve it after you plug everything into the Pythagorean theorem. And don't forget, the last step is to square root. Okay. You have to square root. Then here, the other situation for finding missing sides is that you are given one angle other than the right angle and one side, and you're wanting to find a missing side. Okay, so if you're given one angle and one side and you want to find another side, this is where I would suggest you use trig. You could use the properties of special right triangles for some of them, but here's the thing, guys. This is not a general case. This only works with 3 different specific angles, okay? Trig ratios work with any angle. So use it when given an angle and one side. So the angle it's given should be labeled as theta. It's important to note the right angle is never labeled as theta. Since we're using trig, you need to label your sides with O, H, and A. So remember, the opposite side, or the O is the opposite side from theta. The adjacent side is the one that touches theta, and the hypotenuse is always the one that's opposite from the right angle. Then you use your trig functions. Based on the side that you have and the side you want to find, you need to use one of these 3 ratios. Remember SOHCAHTOA, sine is O over H, cosine is A over H, and tangent is O over A. Then you plug in the value for theta, the side you're given and the side you want to find, then solve the equation, put the trig function over 1 and cross multiply, and solve it appropriately. And then finally, if you want to find missing angle measures, if it asks you to find a missing angle, you are going to be using trig. So you're going to label theta as the angle you're missing, label your sides as O, H, and A, and then choose the correct trig function. And since you're trying to find an angle instead of the side, this is where you use the inverse trig functions. And as always, remember, when using trig, make sure your calculator is in degree mode. So with that summary finished there, let's look at the example problems. There are 16 on this test review. There will be 15 questions. All of them or most of them are multiple choice, maybe one short answer or something like that, but for the most part, all of them are multiple choice. So let's look at number 1. It says, classify the following sets of side lengths as acute, right, or obtuse. Write your answer in the blank provided. So our first one here, since it wants us to classify, we need to identify our A, B, and C value. C is the shortest C is the longest side. So in this case, 17 is our C value. Our shortest side is A, and our remaining side is B. So we do A squared plus B squared and C squared. A squared is 8 squared. B squared is 15 squared. 8 squared gives you 64. 15 squared gives you 225. And if you add those together, you get 289. Now we're going to do C squared. C squared is 17 squared, which is 289 as well. 289, these two are equal. So C squared is equal. Then that means that you have a right triangle. All right, B. B is 7, 9, and 13. Our longest side is 13, so that will be C. 7 will be A, and B will be 9. So we do A squared plus B squared and C squared. So A squared plus B squared is 7 squared plus 9 squared, which is 49 plus 81, which is 130. C squared is equal to 13 squared, and 13 squared is 169. Now we compare C squared to our other value, and we see that C squared is larger. Since C squared is larger, that means this is obtuse. All right, C, 12, 16, and 19. Again, our longest side here is 19, so that's C. A is 12, and B is 16. Doing A squared plus B squared, we get 12 squared plus 16 squared is 144 plus 256, which gives us 400. Then C squared is 19 squared, and 19 squared gives us 341, I believe. Let me make sure of that. No, 361, excuse me. So this is 361. So now we compare 361 and 400. Our C squared is 361, and that's smaller than 400. Since C squared is small, this is acute. And then finally, D, 21, 28, and 35. Our C value is 35. Our A is 21, and B is 28. We do our A squared plus B squared. That gives us 21 squared plus 28 squared. So that's 441 plus 484, which is 1225. Then we do C squared, which is 35 squared. And if you type that in the calculator, you end up getting 1225 as well. So these two are equal, which makes this a right triangle. All right, so that's how you classify each one of these as acute, obtuse, or right. Find your A squared plus B squared and your C squared. Compare C squared to A squared plus B squared. Number 2, Rodney is trying to measure the length of the local pond. He collected the measurements below. What is the length of the pond based on his measurements? Round to the nearest tenth. So it wants to know the length of the pond. Now the length of the pond is this side here. And we're dealing with right triangles. So is that your, so if we look here, we can see that that is our hypotenuse. So I'm going to go ahead and put an H there. Okay. So let's look and see what we have in this problem. We have one side and one angle, and we want to find the missing side. In this case, we need to use trig. So use trig. So our theta is the angle that's not the right angle. So our theta is equal to 61 degrees. We're going to label our sides as OH and A. We already have H labeled. Our opposite side is the one that does not touch the 61 degrees, so that is the bottom side here. And 103 touches theta, so this is our adjacent. We want to find h, and we have a, so we need to use the trig function for a over h, or for a and h, and that would be cosine. So cosine of theta is equal to a over h. Cosine of theta becomes cosine of 61. A over h, a is 103, and then h we don't know. Since we have the angle measure and we're trying to solve for h, we're going to place this over 1, then cross multiply, and when we do that, we get h times cosine of 61 is equal to 103. We need to get rid of this cosine of 61 because it's being multiplied by the h, so we divide both sides by cosine of 61. And we find that h would be equal to 103 over cosine of 61, which means that h is approximately, and we're going to go to Desmos here. Again, make sure your calculator's in degree mode. And we're going to type in 103 divided by cosine of 61, and that gives us 212.5 feet when we round this to the nearest tenth. So that would be our answer. Number three wants us to determine the missing side lengths of the triangle below. Now, you can use the special right triangle properties, but I'm going to use trig. Okay, I'm going to be consistent here and use trig for these problems if we're trying to find missing side lengths and we're given an angle. So since we're using trig, our theta is going to be 30 degrees. And now we need to label our sides as O, H, and A. This side here is equal to our H, it's our hypotenuse, because it's opposite the right angle. 16 does not touch theta, so that's going to be our opposite side. And then our remaining side is the adjacent side because it touches 30. So now what we're going to do, we're going to use trig, and we're going to have to use trig twice. We're going to have to do it once to find A and once to find H. So it's up to you which one you find first. I'm going to go ahead and find the hypotenuse, and then you can find A later, okay? So H, we know what O is, and we want to know what H is. So we need to use the trig ratio that uses O and H. That would be sine. So sine theta is equal to O over H. So we have sine of 30 is equal to 16 over H. Place sine of 30 over 1, cross multiply. We get H times sine of 30 is equal to 16. Divide both sides by sine of 30. And that means that H is going to equal, and if you type in 16 over sine of 30 into Desmos, you get that H is equal to 32. Okay. Now, if you want to, you can use the Pythagorean theorem for here. Just make sure you use your a squared plus b squared equals c squared correctly. Like I said, I'm going to go ahead and use trig again. And so now I want to find the adjacent side. And the adjacent side, we're going to go back to our original side, just so in case we made a mistake here for some reason. So we've got O and A. So the trig function that uses O and A is tangent. So tangent of 30 is going to equal O over A, which is 16 over A. We're going to place tangent of 30 over 1, and we get 16 times 1 is 16. a times tangent of 30. We need to divide both sides by tangent of 30. And when we do that, we get that a is equal to 16 over the tangent of 30. And that gives us 27.71. Now, if you'll notice, you have an answer bank here. So what you need to do is see which one of these matches up with 27.71. So you can look through each one of these, plug them into the calculator, and see which one matches up. I'm going to tell you that the one that matches up is 16 root 3. Okay? And if you had done the Pythagorean theorem with 16 and 32 and you did it correctly, you would also get that same decimal. Okay? All right. Number 4. Number 4, it says, what is the value of b in the triangle below? Round your answer to the nearest hundredth. So it wants to know the value of b. And b is this side here. Okay? So we only have one side and we only have one angle. So we're going to be using trig again. 41 degrees is theta. A would be our hypotenuse because it's opposite the right angle. So that's H. B would be our opposite side because it's opposite of theta. And then 23 would be our adjacent side. Now, since we don't want to know what A is, we only want to know what B is, we can ignore A entirely, which means we have the opposite side and the adjacent side. The trig function that uses O and A is tangent. So we have tangent of theta is equal to O over A. So if we write this out, we have tangent of 41 is equal to B over 23. Put tangent of 41 over 1, cross multiply, and we get that B is equal to 23 times tangent of 41. Typing that in the calculator, you get 23 times tangent of 41, rounded to the nearest hundredth, is 19.99. Because the nearest hundredth is 2 decimal places. So as you can see there, the 3 behind it would not round it up to 20. So B equals 19.99. All right, number 5. Number 5, it says a right triangle is shown below. What is the value of x rounded to the nearest tenth? So the key thing here is we're looking to see where x is. Is x an angle or is it a side? X is in the angle position. So since we're looking for an angle, we know we have to use our inverse trig functions. So we're going to put theta as x, label our sides as O, H, and A. So our hypotenuse is across from the right angle, so that would be 31.3. Our opposite side from theta is the one that doesn't touch, which would be our blank side here, which leaves 24.1 to be our adjacent side. So we have our adjacent side and hypotenuse. So in order to find what x is, we need to use the trig ratio that deals with A and H, and that would be cosine. So cosine of x is going to equal A over H, so 24.1 over 31.3. Since we're trying to find an angle here, we need to use the inverse trig ratio. So we take the inverse cosine of 24.1 over 31.3. And if you plug that into the calculator, I'll show you in Desmos. So we type in inverse cosine of 24.1 over 31.3. And we get that x is approximately 39.6 degrees. Now, I'm going to tell you if you plug this in wrong, like for example, if you type in, if you flip this and it's h over a, so you do 31.3 over 24.1, it gives you an undefined. That means you did it wrong. Okay? So if it gives you undefined, then you need to go back and look at it. All right, number 6. Number 6, it says, what is the length of a diagonal brace that could be used for a wall that is 7 feet high and 24 feet long? So we're looking for the length of the diagonal. And since this is a rectangle, we know that we have 2 right triangles here. So we know we're looking for our hypotenuse. So the wall is 7 feet high and it's 24 feet long. So we know we're looking for our hypotenuse and we're given 2 sides. Now we're not given any angles here, so you cannot use trig. Don't use trig if you only have 2 sides and no angles. So that means we have to use the Pythagorean theorem. So we need to use a squared plus b squared equals c squared. Remember that a and b are your legs. And in this case, your legs are equal to 7 and 24. I normally put my short leg as a and the medium leg is b. And then the hypotenuse, of course, is always c. So plugging those in, we get 7 squared plus 24 squared equals 25. Or sorry, not 25 squared, equals c squared. So then 7 squared is 49. 24 squared is 576. And that's equal to c squared. C squared's already by itself, so we need to add these 2 together. That gives us 625. Then we need to get rid of the squared. Remember, I told you, you need to make sure that you square root to get rid of that square, because square rooting something is the opposite of squaring it. So we square root the c squared and the 625. And if you type that in the calculator, you end up getting that 25 is equal to c. So D is our correct answer. All right, number 7. Number 7, we want to determine the missing side lengths of the triangle below. If you notice, this is a 45, 45, 90 triangle. However, I'm going to use trig just to be consistent. If you remember the 45, 45, 90 properties, go for it. Otherwise, use trig. It's the safer and more consistent option. It's the same process each time. So 45 will be our theta. And that makes the 2, it's a leg that does not touch theta. So it's our opposite side. Then we have our adjacent side here and our hypotenuse, which is opposite the right angle. Again, it does not matter which one you find first. You can find O, or you can find A or H. It doesn't matter. I'm going to find H first. So I need the trig ratio that uses O and H. So that would be sine. So sine of 45 is going to be equal to O, which is 2, over H. Place sine of 45 over 1, cross multiply. And we get H times sine of 45 is equal to 2. Divide sine of 45 on both sides. And when you type that into the calculator, if my program will ever respond here, you're going to get 2 divided by sine of 45, which is 2.828. And if you type the ones that have square roots in them, what you're going to see is that 2.828 is the same decimal that you get for 2 root 2. So h is 2 root 2. And then similarly to the last one, if you know that this is 2 root 2 and this is 2, you can use Pythagorean theorem to figure this out. You can also use trig, or you could say that since these are, since this is a 45, 45, 90 triangle, that the legs are congruent. Okay, so either way, you're going to find that that is equal to 2. And if you end up doing it the trig way, you would end up using O and A. So you would have, at the end, you would have A equals 2 over the tangent of 45. Okay. All right, number 8. Which of the following sets of side lengths can represent the measures of the sides of a right triangle? Check all that apply. So this is where you are doing your a squared plus b squared must equal c squared. If it doesn't equal c squared, then it's not a right triangle. So looking at number 8, you have 6, 8, and 10. Your c value is 10, a is 6, and b is 8. So you have 6 squared plus 8 squared is it equal to 10 squared. If you add 6 squared plus 8 squared, you get 100, and 100 is the same as 100, so this is true. I'm not going to work out each one of these. You can see that on the answer key that I upload, but the answers for this one are the first one, the fourth one, and the fifth one. These other ones will not be your answers. They will end up giving you something that's not equal. Okay. All right, number 9. Number 9 says triangle AZT is a right triangle. What is the length of ZT? So it wants to know the length of a side. Now, if you look here, the only angle that you're given is a right angle. We can't use trig with the right angle, so we can only use these two sides to find the missing side. So we need to use the Pythagorean theorem. So we need to label our values with A, B, and C. Our hypotenuse is labeled with C, and it's opposite from the right angle. So 28 is equal to C. I'm going to label ZT, our missing leg, as A, and 19 is B. Our Pythagorean theorem is A squared plus B squared equals C squared. Plugging our values in, we get A squared plus 19 squared is equal to 28 squared. Simplifying what we have, we get A squared plus 361. And I'll make sure what 28 squared is. And 28 squared is 784. We need the A squared by itself, so we need to get rid of the 361. So we subtract 361 from both sides, and we get A squared is equal to 423. So we square root both sides to get rid of the squared. And if you type that into the calculator, you end up getting that A is approximately 20.6, which is what ZT is. All right, number 10, it says a right triangle is shown. What is the value of X rounded to the nearest tenth? So we're looking for X, and is X a side length or is it an angle measure? Well, X is here outside the triangle on a side, so we're looking for a side length, and we're given one side and one angle, which means we need to use trig. So our 57 degrees is our theta. Our hypotenuse is opposite the right angle, so that means 39 is H. X is touching theta, so that means it's A, and our blank side is the opposite. So we've got A and H. Well, we have H and we want to find A. The trig function that uses A and H is cosine. So we have cosine of theta, which is 57, is equal to A over H. So x over 39. Then we place cosine of 57 over 1 and cross multiply. When you do that, you get x times 1, which is just x, is equal to 39 times cosine of 57. And if we type that in the calculator, we get 39 times cosine of 57, which is 21.2. And we rounded it like that because it says to the nearest tenth. All right, number 11. Number 11, it says, given the diagram, what is the measure of angle Q rounded to the nearest tenth? So right away, it tells us we want to find the measure of angle Q. Since we're looking for an angle, we're going to have to use our inverse trig ratios. So we put a theta on Q. And when we put theta on Q, we're going to need to do our OH and A. Our hypotenuse is opposite the right angle, so H would be equal to 32. 18 does not touch theta, so that's our opposite side. And QB is our adjacent side. So we have O and H. The trig ratio that uses O and H is sine. So we have sine theta is equal to O over H. So 18 over 32. We're looking for theta, so we need to use an inverse sine of 18 over 32. And if we type that in the calculator, we get that theta is equal to 34.2 degrees. So that's what the measure of angle Q is. All right, number 12. Tom is building a floor frame for his triangular birdhouse with wood as shown below. What length of wood would complete the floor of his triangular birdhouse? So the side that he's looking to complete is his hypotenuse. And you'll notice that we are only given two sides, no other angles other than the right angle. So we have to use the Pythagorean theorem. So our hypotenuse is labeled with C. We're going to label our short leg with A and our long leg with B. So we have A squared plus B squared is equal to C squared. A squared is 20 squared. B squared is 21 squared. And C squared is unknown. 20 squared is 400. 21 squared is 441. And we still don't know C squared. 400 plus 441 is 841. Then remember, we need to get rid of the squared, so we square root both sides, and we get that 29 is equal to C. So the length of wood that Tom would need is 29 inches. All right, number 13. Number 13, the diagonals of a square measure 18 feet. What is the length of a side of the square? So for this, it doesn't give us a picture, so we should probably draw one. So I'm going to draw a square here as best as I can. And then I'm going to put in my diagonal. Now it says the diagonal measures 18 feet, which is the length of a side of the square. Now, in a square, the diagonal of a square makes a 45-degree angle. It cuts this one in half. It cuts the 90-degree angle in half. And we want to find the length of a side of the square. So as you know, the side of the square is all, they're all the same. So we're going to put an X on one of those sides. So if you haven't guessed, this is a 45, 45, 90 triangle. But we're going to use trig in order to solve this. So we're going to put theta on 45. That would make 18 our hypotenuse, x our O, and our adjacent side would be the blank side. So what trig function uses O and H? That would be sine. So we have sine of 45 is equal to O over H, which is x over 18. Place sine of 45 over 1, then cross multiply. So you get x times 1, which is x, equals 18 times sine of 45. And if you get a decimal representation for that, I do apologize for the phone ringing.
Call from not provided.
So if you type that in the calculator,
Call from not
your decimal
provided.
will be 12.728. And if you type your answer choices in, you'll see that 9 square root of 2 is the one that matches up with it.
Press the pound key. Good evening. This message is from Carroll County.
So x is equal to 9 root 2, which would be C. If you did this with 45, 45, 90 properties, you would take 18 and divide by root 2, and you'll get the same decimal here, which would be 9 root 2 as well. All right, number 14, in the figure below, what is the value of x? So in this, x is on our hypotenuse, and it's a side, and we're given one side and one angle, so we're going to put theta as our 45-degree angle. Like I said, x is our hypotenuse, and 13, since it touches theta, would be our adjacent side. The blank side would be O. So we have A, and we want to find what H is. So we use cosine. So cosine of 45 is going to be equal to A over H, which is 13 over X. Place cosine of 45 over 1, cross multiply, and we get that X times cosine of 45 is equal to 13. Divide both sides by cosine of 45, and we get that X is equal to is equal to 18.4. And if you type in 13 square root of 2, you'll see that that matches up. So x is equal to 13 root 2. So D would be our answer. The other way you could do it is the properties of 45, 45, 90 triangles, because you have a 45-degree angle where the hypotenuse is equal to the leg times root 2. So x would equal 13 times root 2, which is D. Again, trig works in every case, so if you can't remember the properties, use trig. Number 15, an engineer wants to build a bridge across the length of a lake. His measurements are given below. What should the length of the bridge be to the nearest tenth? So if you look, we're given two sides of this right triangle and no angles. So that means we need to be using the Pythagorean theorem. So the side we want to find is the hypotenuse. So we're going to label it with a C. A is our short leg, which is 41. That leaves 52 to be B. So A squared plus B squared is equal to C squared. Plugging those in, we get 41 squared plus 52 squared is equal to C squared. 41 squared is equal to 1,681. 52 squared is 2,704, equals C squared. Adding those up, we get 4,385 is equal to C squared. We have to get rid of that squared, so we need to square root both sides. So we get C is equal to approximately 66.2. And that makes sense since our hypotenuse is supposed to be our longest side. 66.2 matches up with what we think should be, because it should be longer than the other two sides. And the last one on this test review, number 16, refer to the triangle below. What is the measure of angle D rounded to the nearest tenth? So angle D is what it wants us to find, so we know we're going to be using inverse trig ratios. So since it wants us to find angle D, we're going to put theta on D and label our sides O, H, and A. Our hypotenuse is opposite the right angle, so that's our blank side. Our 6 touches theta, so that's our adjacent side. And our opposite side has to be 23. So we have our A, we have our O. So we need to use tangent. So tangent of theta is equal to O over A, which in this case would be 23 over 6. We're looking for theta, so we need to use an inverse trig ratio. So we do inverse tangent of 23 over 6. And if we type that into the calculator, we get approximately 75.4 degrees. So the measure of angle D is 75.4 degrees. And that does it for this video, guys. I hope this video helps. Please make sure that you watch it and review it as we go along, because you do have a test. Okay. So if you have any questions, please feel free to email me. I respond as quickly as I can. If I overlook your email, just send me another one, and hopefully I'll catch it the second time. All right. Thanks, guys, and I will see you in the next video.